In this video, I will show you a 2D high-speed area mill toolpath. 2D high-speed area mill is used to machine pockets using a smooth, clean motion. Helical entries and tangent stepovers create efficient motion for your machine. Cut parameters let you control smoothing to create the best toolpath, avoiding sharp corners or direction changes. That being said, select Toolpaths, 2D High Speed, Area. When the new NC Name dialog box appears, select the OK button. When the Chaining dialog box appears, select C-plane. Leave the chaining method set to chain as shown. C-plane chains only the entities that are parallel to the current construction plane and at the same Z depth as the first entity you chain. Select the bottom of the pocket as shown. You can now select the OK button to exit the chaining dialog box. The Chain Options dialog box will appear. Again, select the OK button. In the Toolpath Type page, select Area Mill. We will now choose the 3/4 inch flat end mill from the library and set the tool parameters. To do this, select Tool from the Tree View list. Now click on the Select Library Tool button and then choose the Filter button. From here, select the None button and then under Tool Types, choose the Flat End Mill icon. Under Tool Diameter, pick Equal and input the following value, 0.75. You can now select the OK button to exit the tool list filter. In the Tool Selection dialog box, you should now only see a 3/4 inch flat end mill. Select this tool and then choose the OK button. Your tool will appear as shown. Input the following comment. Use area mill to machine the pocket. Once the comment has been entered, choose the Cut Parameters page. Make the following changes as shown. Enable corner rounding. Change the following values. Also, make sure that the amount of stock to leave on both the walls and floors is set to 0. Finally, for the percentage of tool diameter, input a value of 500. I will now take a brief moment to explain a few of these parameters. Corner rounding replaces sharp corners with arcs for faster and smoother transitions in tool direction. Max radius inputs the radius of the largest arc that you will allow Mastercam to insert to replace a corner. Larger arcs will result in a smoother toolpath, but with a greater deviation from the part corner. Profile tolerance represents the maximum distance that the outermost profile of a toolpath with a corner rounding can deviate from the original toolpath. Offset tolerance represents the maximum distance that a profile of a toolpath created with a corner rounding can deviate from the original toolpath. Once all of the parameters have been adjusted, select the depth cuts. Make sure that this option is disabled. You can now select the transitions. Enable Entry Helix and set the radius value to 0.5. Ensure that the rest of your parameters appear as shown. Finally, Select the linking parameters. Enable clearance and input a value of 1. Input an absolute depth value of negative 0.25 if the value is not already there. You can now select the OK button to generate the toolpath. Your toolpath will appear as shown. Next, I will show you how to check your parts using backplot and verify. To backplot the operation we have done so far, select the backplot icon in the Operations Manager. Backplotting shows the path the tools take to cut the part. This display lets you spot errors in the program before you machine the part. As you backplot toolpaths, Mastercam displays additional information such as the X, Y, and Z coordinates, the path length, the minimum and maximum coordinates, and the cycle time. It also shows any collisions between the workpiece and the tool. Select the Backplot tab and ensure that the following settings are enabled. All operations, follow, and leads. You can now select the Home tab. Make sure that Tool and Workpiece are enabled. You can now select the Play Simulation button. Your toolpath will appear as shown. If necessary, you can always select the isometric view and fit icon. This will help you see your part more clearly. We will now simulate the toolpath and verify. From the Mastercam Backplot Home, select the Verify button. Verify mode shows the path the tools take to cut the part with material removal. This display lets you spot errors in the program before you machine the part. As you verify toolpaths, Mastercam displays additional information such as the X, Y, and Z coordinates, the path length, the minimum and maximum coordinates, and the cycle time. It also shows any collisions between the workpiece and the tool. Ensure that the following options are enabled: Tool, Stock, and Workpiece. You can now select the Play Simulation button to run the verify. Your part will appear as shown. You can now exit Verify.